Hello everybody, and we're going to take a look here at the appendix slides of how to go through graphs. And these are helpful when you're looking at economic data and economic graphs. We have a few sets of these appendix slides and I will cover them when we cover their appropriate chapters. So anytime you see a graph, it's just simply a visual relationship between two variables. And we have our horizontal and our vertical axis and our independent and dependent variable. Now, we always put the independent variable is the one that changes first, and we generally put that on the horizontal axis and the dependent variable on the vertical. But in economics, generally we put price or cost data on the vertical axis always, even if it is independent. So this is a little different than graphs you may have seen in math class. The price is always going to be our vertical axis. And remember, we invoke that ceteris paribus notion anytime we look at changing a variable, whereas if we change that variable, everything else stays the same. So a direct relationship is both variables moving in the same direction. As one goes up, so does the other, and we get a line with a positive slope. And here's an example of a direct relationship. In this case, we have income per week and consumption per week. So the more you make, the more of it you're going to consume or spend, and that is indeed a positive relationship. And that's what we're looking at here. As income changes, half of it is then consumed, and 50 is what someone would consume even with no weekly income. The opposite would be an inverse relationship, as one variable is going up, the other is going down, and here's an example of one. And what we're looking at here is ticket price and attendance. The cheaper the tickets, the greater the attendance to an event. This is an example of an inverse relationship. Once again, if a ticket is $50, your intercept where it crosses the line is going to be 0 attendance. And as ticket price goes down, attendance goes up. If tickets were free, you would get an attendance of 20,000. So the slope of a line is what determines its shape, and we'll take a look at that in a minute. So if a line has a positive slope, it's simply vertical change over horizontal change, and in this case we have a slope of 1/2. That's what we looked at before with the consumption to income. If our line has a negative slope, it's once again vertical change over horizontal change, and in this case we have a slope of -2.5. That's what we looked at the tickets versus attendance. You can also have lines with infinite and zero slope, and we'll look at why you can get this later on in this class, but a couple of examples would be purchase of watches to price of bananas. That's an infinite slope. There is no relationship. So what that means is the purchase of watches does not change based on the price of bananas. Whereas you can have a zero slope, consumption versus divorce rate, whereas consumption is going to stay the same once again based off of divorce rate. So in this case, you can have an infinite or a zero slope depending on what variable does not change. If you want to ever look at a line, the equation is y equals a plus bx. Y is the dependent variable, or what you're trying to predict. A is the vertical intercept, or where your line crosses the y-axis. B is the line's slope, which we just looked at. And finally, x is whatever is your independent variable. We can also look at curves. And if you ever wanted to find the slope of a curve, you could use a line tangent to find it. This is not something that I would really ask on a test question, but good knowledge nonetheless. So the slope of a nonlinear curve or an exponential relationship will change along the curve. So if you drew a line tangent, you could find its slope at any one point. Once again, not really something I would ask on a test question, but good knowledge whenever you're dealing with a curved relationship. And a lot of things we're going to look at in this class will have a curved relationship. Once again, these appendix slides are much shorter, but I like to explain them just to go over when you do encounter some charts and graphs, this is what you're looking at.